we, we strive to look it through the eyes of profit, quality, value, and customer. For this to realize, a third eye or an out-of-box viewpoint is a game changer. Today, we are going to get a perspective and key insights in the area of benchmarking and lean design. It is my privilege to have Mr. Mark Limage, Managing Director, Munro Associates UK Limited. He has more than 25 years of hands-on automobile program management and vehicle engineering experience. He offers clients extensive expertise in emerging principle of design for lean factory. Companies like Rolls-Royce, Jaguars, Land Rovers, Cummins Power Generation, NCR, to few new. He has conducted hundreds of cost reduction workshops through the years and trained thousands of design and manufacturing engineers in the principle of lean design. Mark gained a Bachelor of Engineering degree in 1987 from the University of Hull and went on to work on several postgraduate Science and Engineering Research Council projects focused on applying artificial intelligence techniques within CAD. He then moved to University of Warwick to get up a post as a training company consultant. I'm looking forward to the session, like as you are. Over to Mr. Mark. Thank you.
I hope I'm joined in the meeting now.
You're audible, Mark. You just have to share.
Thank you very much. I wanted to thank you for that introduction. It takes me back when you mention all those things that we've been doing over the years, and I'm very excited to be here with you this evening. It's a very nice opportunity for me to share some of our experience and knowledge, and perhaps there's some things that interest you and you might be able to use in your own businesses. So I was going to start my presentation, hopefully, if I can make the technology work for us. Okay. So I hope that's visible to everyone.
Yes, yes, it is.
Lovely. Thank you very much. Okay, we'll carry on. So benchmarking and lean design, something I've been working on for about 25 years, not solely in isolation, but with lots of other people. And I work for a company called Munro Associates, who are based in the States. Our business is probably 60% benchmarking or with some sort of competitive teardown, and 40%, the remaining 40% with lean design consultancy. We do have a large footprint in the automotive industry, but we also touch many other industries. Personally, I have lots of experience in aerospace and white goods and other design environments, including shipbuilding and things like that. So we touch a lot of different products. I wanted to introduce the ideas of benchmarking and lean design by going back to something related more closely to business activity. So product development, this is what we're all involved with. This is what we're all trying to improve. And I often think to myself that target setting and engineering are two things that we do very often, but perhaps not as well as we should be doing. And by that, I mean, I often find that companies are pretty poor at developing their targets. They have loose targets or no targets. And that, given to the engineering, means that you don't get a business solution to the product. What you get is a functionally engineered product that is capable of doing all the things it wants to do, but it's not necessarily a business solution that makes money for the company and makes profit. So I like to see that lean design, or I like to think that lean design and benchmarking contribute to better forms of both. It's very important that we see these as part of the integrated activity for engineering and product development. The lean design aspect, in whatever form you take it, and the benchmarking, however you do it, are very important to being successful product development companies. There's lots of influences on how you might do both. The outside influences and internal influences that mean you're better or find it harder to achieve these things. For benchmarking, obviously, availability of competitor products is sometimes an issue. And I think in one of our last sessions, we talked about how low volume, high cost products like jet engines and things like that are fairly hard to benchmark because there's no availability to you as a benchmarking agent. So the thing to remember in this kind of environment is that you can benchmark other industries looking for other technologies and other materials that can help you. You may not directly look at your competition, but you can look at the engineering environment to help you produce a better product. So the thing to remember out of this is what you're going to get out of benchmarking. You're looking for knowledge and understanding. I often say it's not copying, it's knowledge and understanding, because you have to know how to apply the information that you develop. And lean design is about an elegant design and a profitable business case. An elegant design can be anything really, but it's how the design fits the business. So we might be talking more less about style and how good it looks, and more about how easy it is to produce, how many parts are in the product, and what effect it has in the factory. Is it easy to put together? Those kind of things. And then over that is, can you turn a profit on the product you're manufacturing? So this is trying to set the scene for you where benchmarking and lean design fits in a product development company. So benchmarking is really about understanding your relative position to your competition. It lets you know where you are and how competitive you are, not just in terms of how many sales you have, but how many parts you use, what technologies you use, those kind of things, how you're manufacturing. This then allows you to identify targets for your new product development. You must know where you're going to. I find I'm in a company where the engineers don't have defined targets for their own system. There might be, say, if we're in automotive, there might be a vehicle level target for weight, but there's no engine specific weight target. So it's very important that you give engineers a target to develop to. Benchmarking also helps you find new processes and new materials. And as I said, it's often beneficial to look outside of your own industry for those things. It also helps you understand the business case of the competition. Quite often we find that you're competing with a competitor who may be a larger organization. And if you follow what they do, you'll end up in trouble, because maybe they have high levels of vertical integration in their business, which means they can use products from other business units to support their delivery, things that you can't do. So you have to understand what other people are doing and then find a way to compete. And it's all about competition. It's about creating a world-class design. That's how you develop your product, looking to be world-class in whatever you do. So benchmarking, as I've said, is understanding and preparation for innovation. This is what I really like to get. You can't just look and copy. You have to look and innovate. That's how you challenge the marketplace. So benchmarking for us, as I've tried to say, starts in kind of this way. I always like to see, if I visit a company, how much technology and process information they're gathering, how much material knowledge they have. So somewhere like this might be a vision of a technology room where you can go and you can push your engineers to go and look and see what other people are doing, in terms of not perhaps the detail of your design, but the detail of other processes, other technologies that they could imply to improve your product. Benchmarking, of course, is also the detail of taking a product to pieces. And the thing to note here is, if you can, you need to get hands-on knowledge to truly understand. So we always work to try and get the engineering team to do the disassembly wherever possible. Sometimes it's a secondary department that does it, but it's always good to get engineers into the benchmarking and teardown center to do their own investigation of products. And finally, you must disseminate the information. It's no good writing a report if nobody sees it. So you have to find ways of getting the teardown benchmarking information into the hands of the engineers. And then I've said the best way is to get them to do the job. Other than that, you must actively go out and push the information to your engineering teams. And that's helped by having better targets, because if they're under pressure to deliver on a target, they will often look for different ways of doing it. So that's benchmarking, the style, if you like, or the key features that you really need to implement if you're going to be successful and use the benchmarking ideas and tools to their best effect. One of the things I wanted to just illustrate, it was a long time ago now, we did a study on a Toyota Matrix, and it was interesting at its time, but the example I wanted to give you tonight was the fact that we looked at how many fasteners they had in the car. Something you may not look at just when you approach a vehicle and you're looking for technology and things like that, but it's an important measure in terms of engineering. It's an important measure in terms of business, because you think of all the effects it has on manufacturing in terms of you know, just tightening bolts. Just looking at it, just as simple as that. So we set up these boards. We pinned every board, every fastener we found to a board, and checked that it wasn't duplicated somewhere else. And what we found is almost 1,000 fasteners in this car to put the major components on. But an interesting fact is there's 270 different types of fastener. So very little commonality across the type of fastener, and a lot of fasteners individually. If you notice the lift gate, there are 24 different types of fastener in that, and 21 of those 24 are unique. They are one-off to that particular system. So how is that? Is that good engineering, or is it poor engineering? For my mind, it's something that can be improved. You may see a different side of it. I wanted to point out what we thought was the learning point from this, and what I still take as the learning point from this. Toyota buys quality fasteners. Each one of those items was properly made and without fault, and you know, a quality bolt, if you like. And the other thing to note is that they are very, very good at adhering to process standards. So each bolt, when it's torque tightened, they're all tightened to the same level and same degree. So very high adherence to process capability there. The bad point, as I've just made, is a variety of fasteners, a big variety of fasteners, and a lot of individual fasteners in the count. That's the good and the bad. And the learning point from here is Toyota is very, very good at some things, but they can still improve. Just imagine how powerful it would be if they could get control of the variety and the number of fasteners on their product. So I wanted to say, looking at fasteners in the very bottom of the pyramid, if you like, in terms of benchmarking, very specific notes I've given you in there. I wanted, if I can, to just try and illustrate that with a couple of minutes from a video. I think some people are aware that Sandy Munro, the founder of our company, does a lot of videos explaining our teardown activities, what's going on. And I wanted to pick a couple of minutes out of this just to allow you to see how that goes. But I wanted to take it to a much higher level. So it's okay to look at the fasteners and gather numbers on that. But at some point, you have to bring the engineering activity up to a system level so that you understand how saving fasteners and changing the design actually works. So if I just drop out of that for a minute and go to my video and share. No, doesn't seem to be working. Here we go. Wrong one. There we go. So I'm just going to show you a couple of minutes. So here we go.
Mark, we're not hearing the audio. So.
Okay, let me pause that. Have you a tip for me as to why we're not hearing the video?
Yeah, say share and then share the video clip. Yeah, choose that option.
Let me try that. Okay, there we go. Let's try it again. Sorry, I hadn't clicked the appropriate buttons. So let's go again. Hopefully you'll get this. So this is the Tesla Model Y thermal system, and which is a unit we benchmarked a while ago. And it's just interesting to compare that with the newly introduced Ford Mach-E, the same system, the thermal system.
Bring the corresponding pieces and parts that we found on the Mach-E, put them on the table, and then compare and contrast the hoses and lines that run between them. Right here is the R1234YF pump. Notice it's hanging off of this cross-car bracket from the Tesla Model Y. Tesla chose a steel bracket to go across, Ford chose an aluminum. But as we look at how things are mounted, how they're isolated, and the distances apart, we can see that Tesla focused heavily on getting everything as close together as possible. If you look at the back, because this is a heat pump system, the lines run in an exact straight line. When comparing and contrasting to the Ford Mustang Mach-E, you'll notice that the lines are not nearly as concise. So Ben, do you want to go ahead and grab the first component to compare, and we can talk through the differences?
All right, well, first we're going to grab all the lines that the Mach-E has, which is, as you can see, a whole bunch of lines when compared to what the Tesla Model Y had. There's actually 35 different hoses here, which is a very large number when looking at the thermal system. And then pulling out a few of the other parts that Corey had just talked about, we'll start with the bracket that they're using for mounting most of this. This is the crosscar beam. This also holds the motor up as well as the electronics. So Ford is doing more than just the thermal systems with this component. So it is much larger than what it needs to be, but it would be the equivalent part in the Mach-E. And then we also have the compressor that the Mach-E is using, but it's not mounted just like that. There is a noise isolating diaper that goes around it, and they have a bracket and then an isolator to hold it in place. So there's a lot more that's happening with these parts. And then Corey also mentioned the refrigerant lines there and how they were very straight and to the point with their design. These are very turned, they're very bent, not a straight line ran here, so they have to wrap around parts to get to where they need to be.
Okay, I didn't want to take that too long. It's one of our YouTube videos that you can pick up on YouTube, and you know, if you're interested, you can go back and look at it in greater detail. I'm hoping I'm picking the right screen. Here we go. So hopefully I'm back to the presentation for everyone.
Yeah, yes, Mark.
So,
yeah.
thank you. So that's an illustration of how when you do the benchmarking across systems, you can see immediate difference between the Tesla and the Ford. Why they ended up like that is open to speculation, but it's probably because Ford didn't look at the Tesla system in terms of benchmarking, and they looked at other systems. When we've noted between vehicles like the Tesla and the Ford Mach-E, some areas are truly fantastic on each car, but nobody does everything really well. And so it's important to note that, you know, Ford was still designing here a distributed system across the car when Tesla have already showed another way of doing it. So interesting point, but just to get you, there's the Tesla system. And here's everything that was equivalent on the Ford Mach-E. Now, you might say, well, you know, Ford had to live with other constraints, maybe different sets of suppliers who did something. Maybe they were carrying over a lot of parts and wanted to reuse those from their parts supply bin, that kind of thing. But you have to look at a higher level, which is why I think target setting is so important. In the video, Sandy and the team draw out some numbers, some comparison numbers. And I just wanted to illustrate it here with the thermal hoses. You saw how many were put on the desk for the Mach-E. If you measure the length between the two sets of hoses, it's 18 meters versus 6 meters, a remarkable difference. Part count, 35 versus 10. You know, it's an effect of distributing the system. You get more parts. But the interesting thing is, if you look at the weight of the fluid in the system, it's 22 kilos versus 9 kilos. And you may say, well, you know, that's just an effect of how you design it. But think about it for a vehicle level. If you're carrying around an extra, what is it, 11, 12 kilos of fluid, you're reducing your range by that much in an electric vehicle. So you're having a detrimental effect. And if every system like that, then you start to see a vast deterioration in range on the vehicle. And that's something the customer doesn't like. So, you know, weight here, whether it be the weight of the fluid or the weight of the parts or the number of the brackets, is very important thing to understand when you're benchmarking. So we go from the detail to right to the high level of the vehicle target setting in that regard. So switching to lean design, how does this play together? Lean design is about changing the rules, changing the engineer's mindset. You want the engineer to think a bit differently, to see a bit differently about the design, and also to implement a different design. In my experience is that within a company, the engineer gets constrained by faster delivery times and things like that, and reusing supplier parts. So if you're going to do this, you have to expect change and you have to allow the engineers to deliver change as well. We've all seen this graph 1,000 times before, and it's intuitively obvious that what it's trying to say, it's cheap to fix a problem early on, and it's more expensive as the later time goes in terms of the development phase. And certainly it's very expensive when you have product recalls and things like that. So cost of product failures, faults and failures over time. The thing that most companies don't do is understand or measure where engineering change happens. So if you look at that, typically there's lots and lots of engineering change happening early on in the development phase. And this is often not recognized. It's certainly hardly ever measured. And then it drops off as we go through the development phase to a point where we say issue the design and then start to look to buy tooling. And then it'll ramp up quite significantly when we get to testing and we find test failures or parts that don't fit and things like that. Then it drops off again, and hopefully we don't see it, but sometimes you do. You see failures in the field with the customer, and that's really expensive. So this is an important thing to note, where the failures are occurring. The question that we should be asking is when can product design be most influential on this? i.e., how can we reduce the number of failures we've got? And it's fairly obvious to say that this is early in the design phase. The earlier we can get in and fix those problems, the better off we're doing. But actually, you're only fixing problems that cost you money downstream. You're not actually changing the business case of the product necessarily. This is where lean design differs in some respect, because actually lean design is influencing the profit you make, not just taking away failures, but influencing how much money you're going to make on a product. This is where we talk about the influence of the product design engineer, not the fact that we're maybe working with suppliers to reduce cost, or working with labor, or changing the factory to reduce cost. It's how the engineer influences all the downstream costs in the process through the decisions that they make. If we can make the engineer make better decisions, more business orientated decisions, then we're really going to make money on a product and not just have what I typically see is a very functional product, one that does the job, but doesn't necessarily fit the business case or deliver the targets. So everybody knows about lean manufacturing today. It's well instigated in manufacturing businesses. And there's lots of processes that you can implement and tools and techniques that you can use to deliver lean manufacturing. But one of the important things is waste. Lean is all about the reduction of waste from a system. So I've been thinking and constantly trying to refine the idea, what's waste in terms of a lean design? In engineering terms, where's the waste of what the engineer does? And I've been thinking about this. So first couple, very closely associated, over specification of requirements, tight tolerances and extra processes for manufacturing. If there are things you can do to refine that, then of course you're making a better business case. Just a very simple example. Here's a cap screw and a washer. They're quite innocent parts. There's no particular science about using it. We're just trying to bolt two parts together. Actually, there's 4 parts in here, and you have to say that's fine. That's standard engineering. How much would you expect the cap screw and the washer to cost? And until you start saying, well, it's functional, but how much is it costing my product? This is when we started to open our eyes. And you see here that the washer costs $1.50 and the cap screws cost 97 cents. Not very standard prices for relatively standard parts. When we get into it, the cap screw is a fairly standard part, but it's for the industry. It's a fairly high strength bolt. The washer is the interesting bit because it's actually specified to 4 decimal places of flatness or thickness. So it's a really highly constrained part. That's where the money comes from. It's probably got ground surfaces on both sides. Totally unnecessary for the requirement of the job it's doing. And there's a simple saving here. And you may say, well, Mark, that's very detailed, but it's only saving, $5 on a $1,500, $2,000 piece of kit. Well, you have to look at the detail to start building up. And you ask yourself, why does the engineer use such an expensive bit? And it's generally speaking because it's standard or it's been used before in their industry. So you have to shine a light. You have to ask the engineer to think differently about the job that washer's doing and what its requirements were. There's no particular flatness on the on the casting surface that's machined. There's no particular flatness under the head of the bolt. So why would you put such a highly specified part in there when a cheaper one would do? So that's, over specification of tolerances and requirements there. There's other things like long lead chains. I've met several components that have done 24,000 miles before they've actually hit the assembly line in terms of being prepared and machined and manufactured. Is there an opportunity to reduce that sort of thing? Multi-touch assembly where parts are assembled and then disassembled and, touched again. I'm sure you're very familiar with that kind of thing. Late communication between functions. Poor communication between functions often costs you a lot of money. One of the worst things I see, or one of the most obvious things I see, is quality and warranty issues. Just because that information isn't fed back to the engineering team, I see that faults and failures occur in every introduction of the new product. It's always there because the information is not fed back to the beginning of the loop. So these are forms of waste as I see it. There's 2 more that I wanted to illustrate. Unnecessary parts and stifled innovation. Waste of the human mind, if you like. Here's a very obvious change. Unnecessary parts on the left, a refined design, shall we say, on the right. And it's easy to see how you could make that change and come up with a suitable product. The problem is if you didn't implement it. And this is a catch-all to all management. If you're going to do some lean design, use the outcome of that product. It's a source of dismay to me if we have an engineering team working hard to come up with new designs if they don't get implemented. So a word of warning to some. So we train the engineers and we do workshops on site mainly. We've been doing some web-based activities to try and work through the pandemic. Very hard when you work with distributed teams that may go all the way from Europe to the far side of America and that kind of thing. So it's hard work. But we train in the lean design process and we deliver workshops to make sure the engineers are doing the right thing on a product. And it takes, 1 or 2 goes at this before the engineers are self-motivated and doing their own lean design on the product. So I'm training the engineers to think about things differently. And I want them to understand that they are the ones that create profitable products. So it's not just a functioning product they have to do, but they have to use the targets that have been set to create a product that delivers for the customer and one that also delivers for the business in terms of its business case. Just mentioned working to targets. Those targets have to be detailed and specific to all the engineering teams, not just at a platform level or a whole product level. They have to be broken down so that specific engineers know they have a task. Otherwise, the engineering community tends to pass those tasks around and they never get delivered on. The engineering process or the lean design process is one that's based on numbers to measure your success. And sometimes those numbers don't actually quantify in business case terms, in pounds and pence or dollars. But you have to have numbers to say maybe, well, we've saved having 50 parts in a design. Maybe we started with 100, we got down to 50 or 10 or something like that. That measure is not quantifiable in a business case, but it has a big effect in terms of the number of suppliers you have or the length of the production line. Those kind of things all come into play. So numbers prove a case. Think differently about the design, challenge your preconceptions. The conceptions I find are often out of date rules and regulations or unsubstantiated evidence about customer requirements and things like that. So always make sure that when the design is in a lean design environment, we're operating to the latest information on its requirements. And we're always looking to find the waste in the design. That's the key to doing this. Now, saying that's how I train the engineer, there's a refinement to this, which is a lower level of detail, which allows the engineer to actually operate when they're looking at the parts they're designing. So 2 of the key things that we like to talk about are minimizing the part count and considering assembly while designing. We have very simple tricks, if you like, to play. So we have a part value challenge, which really focuses the engineer's mind on saying, can I integrate components? I may need the function, but do I need separate parts to deliver that function? So we go through a process of asking the engineer to look at all the components they have and say if they can integrate parts together, but not remove any function. And we also have some good design principles for assembly. So correlating to the last point is minimizing the number of parts. Obviously, if you reduce the number of parts, you have a shorter assembly line. Use gravity, don't fight it. If we can make a bottom-up assembly, something that we can just pile up, that's the most efficient process we can have. And designing like that takes people a long time to understand how they can fit parts in a layered fashion that builds up. And indeed, one of the videos that I've alluded to before, Sandy Munro, the owner and founder of the company, goes through a process of reviewing one of the inverters off the marquee, off a VW ID3. And he shows quite clearly how the parts are fitted into that product in a layered fashion. and that makes it very easy to build the product. The other thing I like to maybe point out or highlight is questioning serviceability on a product. The customer always likes reliability, not serviceability. So I often have to coach the engineering teams around to the idea of what needs to be reliable as opposed to what is disassemblable because it's serviceable. And there's a slight difference. And the final one I wanted to highlight is the need for adjustment in assembly. Often engineering teams will leave a tolerance stack. That means that the manufacturing operator, the manufacturing engineer has to figure out a way of getting everything together so that it works. And that's waste because perhaps there's a design solution with a bit more thought or some more money spent that would alleviate that problem on the factory floor. So always think about how you're going to build the product as you're designing it, not as a subsequent operation to the design and development process. And kind of to illustrate that, this is just a picture of a body shell. It's actually the Tesla Model Y body shell. And in most standard cars, I think 600, 700 parts in the body shell, lots of press parts, spot welded or welded together or glued together to form the shell of the vehicle. When we got hold of our first Tesla vehicle, the big criticism that came out immediately was the fit and finish of the panels. There was lots of variability and gaps all across the vehicle, and it particularly at the rear end. And what our conclusion from this was that they had no build capability, process capability in terms of how they were building the body shell. I'll say a note here that other parts of the car are absolutely fabulous. The electronics they'd instigated, they'd clearly spent their time designing those bits and not so much on the body shell. But, you know, in terms of customer perception, those are the things that grab your attention from the outside of the car. Those are the things that you wouldn't find on other brands of vehicle where, you know, quality is premium. So gapping was variable across the whole car, front to back, side to side. The reason for this, as I've alluded to, is that they had lots and lots of body panels and they didn't control the build-up. So we criticized them heavily from that. And just to say there's no actual relationship between Tesla and Munro. We just took the product and started looking at it because it was probably the first easily available high volume production electric vehicle, and it was interesting to do that. As I said, but Tesla, one of the good things about Tesla as a company is how quick they are to respond to faults and flaws. So they immediately reacted to this, and then on the next vehicle development they looked at all those rear body stampings, and they came up with a solution which was a single piece casting left and right. So they replaced those 70 stampings with 2 die cast elements, and they called it the mega casting. It was interesting when we saw that, and perhaps a year or 18 months between the introduction, they'd managed to get it in. And now Tesla are actually going further. Rather than having 2 castings left and right hand side, they're actually talking about, oh, I wanted to get that in. So, you know, this is a proof of the point here, if you like. As variation is reduced, quality will increase. Well, there we go. If we go back here, the variation between all those 70 parts and their own particular tolerance stack up is blown away when you only have 2 parts on a high quality die casting. And Dr. Deming was absolutely right when he said that, and probably, you know, decades ago. And this is just proof of it when you see it instigated in a design like that. The correlation to this is all variation stems from design. It's going back to how the designer thinks and what they're thinking about when they're doing the design. It can't just be a functional design anymore. It has to be one that suits all the requirements of the business, whether it be business case or manufacturing tolerance stack up. And the final bit of this story was that Tesla are now going for a 1-piece casting side to side on the rear, and it actually extends forward of the rear wheel arch to take up a chunk of the car. And as you see at the bottom there, They've got rid of 370 separate parts. It's a 10% mass reduction on the car, leading to a 14% increase in range. So all the good points coming out in terms of benchmarking where you are, understanding what the customer needs, setting targets, and then delivering with new processes and adapting what you have to deliver a better product. The best design is the simplest one that works. This is something that we like to hang on to because, again, in Munro terms, there's a correlation to that. And the correlation is the first design is never the simplest. And that's something to hang on to, whether you're benchmarking or doing a lean design activity, is what have you got in front of you and how can you improve it? What have you got in front of you and what are the measures you need to note to improve your design? What have you got in front of you? How much does it cost? And how can I beat that? So always think of things in these terms. Is that your first design? Is that the one you're going to take to market? Or is there a refinement process that you can go through? So I don't know how long I've taken, but that was really where I wanted to get with you this evening. Thank you for listening. Thank you for your time. And now I throw it open. Is there anything anybody'd like to ask?
Okay, thanks, Mark. Thanks, Mark, for your presentation. And let me pick up some questions in the chat box. I see one coming up, so let me do that. And anyway, thanks for the wonderful presentation. And before we pick up some questions, straight questions to you. Now, how do we generally start this process if you are into if you get into start, can you briefly tell me step 1 or step 2, where do we start?
I think you start with benchmarking. I think you have to understand what the competition's doing. And then you can move into actually challenging the engineers with some targets so that they can define and refine the process. And that's perhaps where we come in later on, in the process to actually ask them to do the lean design workshop. And from an outside agent's point of view, we can push a little bit harder. We can ask them to do other things. We can also suggest things because, as I mentioned earlier on, I go to a lot of different industries. So it allows me to bring in new techniques and technologies from other companies outside of whoever industry, whatever industry it is, outside of automotive, to introduce maybe an aerospace or a medical way of doing things. So start perhaps with benchmarking, know where you need to be, and then you can use that information to guide and move your engineers forward.
Okay, I see some questions here. We'll just pick up a few from the chat box. So there's one question: how to look at manufacturability? This is a question from Mr. S. Kumar.
Well, thank you. I think I kind of start from the design end. So I'm going to say your manufacturability will improve if you've designed the product correctly. So I like to think that if I can reduce the part count from an engineering point of view, if I can go from 100 parts to 50 parts, then my manufacturability increases. It becomes easier to make the product. I've got less parts to cater. I've got less assembly activities to do. If I've got less parts, the quality of those parts should improve because I've got more time to look at each component, if you like. That's how I see it. Manufacturability, I guess, is measured in right first time throughput, maybe, or just time to build the product. All good measures, and I think that stems from design to try and deliver a manufacturable product. It's how you designed it. I often see a product that is very functionally capable, but very hard to build. And it's when we can get the two teams, manufacturing and engineering, working together, that's where we get the benefit and the manufacturability.
Okay. One other supplementary question from side on behalf of all the audience is that, can you give us some idea on the benefits in terms of a product costing once you get into it? From your experience, what has been the kind of some numbers, some percentages?
Okay, that's quite hard to do because it varies dramatically from industry to industry. when you're in an industry that has a product that's historical, that's been refined over decades, it's quite hard to introduce easy changes. It would have to be radical changes to that industry to make a benefit. So in that kind of environment, you might see a 7 to 10% change. If you go to industries like shipbuilding or low volume things, like I mentioned shipbuilding, then it's easier to make a bigger change on a product because the advances you're able to do can sometimes be more dramatic. So if I said 10% would be a saving, a product cost saving, that's quite a conservative expression of what might be possible. It just depends on which industry you go to and how long people have been working on that product.
Okay. I'll just take one last question before we go on to the next important aspect of today's session. One is there's a question from Mr. KVSS Iyer. Variations stem from design is what you mentioned. So he wants you to elaborate it a bit.
Well, I think it's Dr. Deming again. He had it all, absolutely right. I don't know, many years ago, shall we say. So variation stems from design. If you have a high part count, then you have a lot of variation. Each part has its own tolerance on it. The tolerance stack up builds up, and therefore you get product variation, whether it's being gaps on a car or functionality that you're delivering in a medical device or a high resolution camera. Those kind of things happen. So simply put, in my mind, the more parts you have, the more variation you have, the more potential variation you have. So that's why we concentrate, and one of the things that we go for in our engineering workshops is part count reduction, part count reduction, part count reduction. If you can do that, you inherently get a quality product at the end of the day. Okay. There's always fluctuations in process capability and refining a process that, whether it be surface mount technology for PCB boards or maybe how you cut steel. You can always refine those processes to get better quality. But again, I'm a designer. I start from design. I believe that design is a key to delivering a better product. So that's what we have to do.
Right, Mark, thanks. I think I'll probably pass on the other questions to you directly, and then we can probably touch base with the audience. I see a lot of questions.
Thank you.
But I think we will address it offline with the respective participants. Okay,
lovely, thank you.
Yeah, so thanks for the presentation and the Q&A. So I would now request, Mr. Rajkumar to introduce our guest of honor. First of all, of course, Mr. N. Ramanathan, popularly known as NR, does not need an introduction in a session in ISQ. But for the larger audience, I certainly want, Mr. Rajkumar to introduce him formally. So, and I think ISQ is a vision, and vision has been set by Mr. NR, and so I'll leave it to Mr. Rajkumar to give a formal introduction of our guest of honor and our mentor of ISQ Chennai chapter. Over to you, Raj, for a brief introduction of Mr. NR. Raj, you are on mute.
Thank you, Mr. Nandakumar. To add to this limelight, we have a well-renowned Mr. N. Ramanathan, a senior counselor and advisor of TQM. NR San is the guru on TQM to most of us. It's a really honor to introduce him. He has established the Quality in Planet Earth Concerns think tank for the International Academy for Quality, IAQ, shortly as IAQ. He has presented and published numerous papers on sustainability and connection to quality. In 2021, he has helped ISQ establish the Quality Earth Forum, which is now a national partner to the Quality Sustainability Award of IAQ. He is the vice chair of just established IAQ think tank on Quality 4.0. He has collaborated in creating the newly announced ISQ vision and mission, which embrace the idea of healthy planet and thriving humanity. As a counselor, Enna-san has been associated with 12 successful Deming Prize challenges in India. Enna-san was recently awarded the prestigious Edward Medal for American Society for Quality for Outstanding Leadership. Besides other international awards for his work, he has received the Dronacharya Award from ISQ in 2018 for his contribution to teaching and counseling on quality. Enna-san is a mechanical engineer with a master's in IIM Ahmedabad, 1969, with 52 years of experience in industry and in teaching and counseling. Over to Enna-san to share his views about the session, and we are waiting for his direction in future. Welcome, sir.
Thank you, Rajkumar. Thank you, Nanda. Thank you for your very generous introduction. It's really a privilege for me to be here, but I want to start by saying that I'm very excited, Mark, today. It's an exceptional talk. There is so much of depth in everything that is said, and it is obvious that what he said today was only a small glimpse of whatever there is to learn from him. I wish there would be opportunities for many of us to listen to him in a longer program sometime. I, for one, would be very delighted to attend it and learn. Thank you, Mark. That was really an outstanding presentation. One of the best that I've had the privilege to listen to in a long time. Thank you very much. Now, I'm only going to speak as a guest. I don't have to make a presentation. So first of all, I would like to start by what Mark said about targeting and targeting being weak. And as we know, one of the strengths of total quality management is its methods of target quality, target costing, and target sales, and so on. As some of you might know, I used to head the joint venture in India with Denso, who are one of the most advanced practitioners of lean as well as TQM, and of course, were pioneers of TPM. And when we designed the products, I'm talking about a long time ago, 30 or 35 years ago, they used to do the target costing of parts to the second decimal place of the yen. There is no such currency, of course, but their idea was to get it down as precisely as possible because it all adds up when you make them in thousands and millions, and there are hundreds and thousands of parts. They all add up to a huge sum. So that is how much of emphasis they would place on target costing, and of course, target quality as well, and targeted quantities. Mark talked about fasteners, and he mentioned Toyota. I remember the struggles that we used to have with Denso about fasteners, because they were very sticky about adding any new fastener design. They had a library of an immense number of manuals. Those days they were physical manuals about fasteners and what you can choose and what you cannot choose for various applications. And they'll try and minimize the proliferation of the number of fasteners. Mark also talked about hose design and its relation to the system, and the importance of straightness. In sustainability, we talk about designing something or even an installation of a large equipment with the piping and the tubing and such things first, along with the motors, because if you can design them first and then fix the installation of the equipment, you probably have the right size of tubes and pipes so that you can reduce friction, you avoid bends and so on. And then you cut the size of the motor drastically. So this is the same principle. The whole concept of looking at the system as a whole first, together with all these pipes and cables and so on, rather than trying to fit the pipes and the cables and the hoses subsequent to the design of the main thing. So I think these were things that were so well reinforced from Mark's talk. Thank you, Mark. I know a little about lean design, having worked in Denso, not too much. But I know that the term lean itself is a Western term, which was picked up by John Krafchick in 1987, working in MIT in the project on the Toyota production system, along with Jim Womack and Dan Jones. So in a paper in Sloan Management Review, he called it lean. And Jim Womack once said, when he was in a visit to India, and I asked him, so he said, it was something that was proposed by my student and we liked it. And I asked him if it's any different, he means anything different from Toyota production system. He says, no, it's the same. So, but lean is a word that is caught on and far more than a very cumbersome term like Toyota production system. And it's anyway more than a production system. So I'm happy to use the term lean. In the old days, Dr. Ishikawa would maintain that TQC, as it was then called, really starts when it is applied to new product development. So we all start TQM activities generally downstream with manufacturing and sales and so on, and then move up to new product development because that is a convenient way of implementing. But the real bite in TQM is in product development. The principle has always been, and Mark mentioned this very clearly without giving this percentage, but I can add a percentage to it, that 80% of quality and costs are fixed upstream before you make a single piece of anything. The goose is cooked by the time you start. 80% of management time is spent or wasted in the downstream problems which are created upstream. And that's why design is so important. A number of studies have, since the times of TQM, been made, especially in the Western world, on the product development system in Toyota. And these have acquired the term lean design or lean product development. One of the things that we should talk about when we talk about lean product development is the organization structure for product development, especially in the automotive industry, which was the focus of Mark's talk today. The work of Cusimano talks about maximizing both the cross-functional organization and inter-project coordination. So that's the kind of organization structure that has evolved. It wasn't there 30 years ago. It's something that has happened in the last 10 years, including in Toyota. And this enables engineers to work simultaneously on more than one project. Typically, each engineer works on 2 or even more projects at the same time. Now, we know that lean methods in design can cut development time, resource use, and the initial quality problems that occur when the product is released by a factor of 4 or more. It also definitely helps in avoiding schedule overruns and cost overruns. But before I move with that, I also want to talk about extending the principles of lean design to the Industry 4.0 type of situation and the digital transformation that we are now talking about all over the world. Paradoxically, I would say that the world of the digital transformation has begun as an era of glitches, as they call it. Many of these products tend to be susceptible to errors, glitches, bugs, or problems, or whatever you might call them, that can be tolerated by advanced users and early adopters, because the principle is to release the product early and then work on it. But then these get carried over to the regular users who cannot handle it and are intimidated by them. And the service to settle these problems are not easy to get. Help and support desks sometimes feel like cruel jokes. Now, the point is we must remember that these new digital technologies have delivered, in Professor Kano's terms, attractive qualities as never before. But there must be qualities which include the glitches that we talked about and are often suspect. Technology hassles have become a new normal, converting digital frustration into a way of life. Now, these are not harmless problems. Without elaborating it too much, please think of the Boeing crashes, Boeing Max crashes, which happened, as we know, out of the digital domain, and not out of the hard mechanical or electrical domains. Now you have recently in India, Mark will not know this, the glitches, as they call them, with the tax portal designed by Infosys. We don't know yet where the problems were created, but a whole bunch of problems have been detected after release. And Mark showed you how much it costs extra to solve the problem at that stage, right? These are major problems, actually. Now, if you do have problems at this stage, you have to analyze them. For every problem, we have to analyze in a T matrix or whatever, where it was created and where it was detected. And the longer the gap, the greater the magnitude of the problem. And the earlier it was created, the harder the problem is to cure. So a T matrix is what we normally use, but I wonder if the modern digital world knows how to do such things. They just live from day to day and act as though, oh, well, the problem is solved. Now let's go on to the next one. So where is this learning of lessons for the future? So we have to learn lessons continuously. And when our learning stops, we also start decaying. So it's not something which is a mild thing. So when we stop learning, it's a significant problem. In this particular case, we don't know whether new products were brought in late by the state, and which the company could not refuse because of their inferior position vis-a-vis the government, nor change the schedule, but we don't know all that. But the principles of design and the avoidance of troubles early on is very important, as important in the digital world as in the mechanical world of automobiles and so on, the physical world. So some aspects of lean design, which I have understood a little bit by observing it in companies that I visit, are just as in production, lean product development also creates a cadence or a rhythm and a flow and a pull. So very similar concepts apply to the whole design process. Now, some more concepts are to start the project before everything is pinned down. So in fact, you have a negative reaction time. So at the concept stage itself, you start the project a little bit. And therefore things happen in a sense, in a concurrent engineering way, in parallel. Now this means, for example, that you don't ask for vendor bids, because if you want to ask for vendor bids, then you need to have your full specifications, etc. And then the vendor makes you a quote and so on. The RFQs are released after a full specs. But that's not how Toyota does design. In Toyota, even as the specs are nowhere near complete, they start working with their vendors. So they explore what the vendor can actually do to design and improve the part or the product, as the case may be. Toyota does testing to the point of failure and used to develop trade-off curves. I understand computerization has made trade-off curves a little obsolete, but they used to make trade-off curves to do testing to the point of failure and not just testing to the specifications. So they also do a lot of quick, low-cost tests at early stages. In recent times, as you may know, Toyota has eliminated, at least for many cars, the shower test. Now, the shower test is a holy cow in manufacturing of cars. They can't do without it because no matter what you do, some cars seem to leak water through various gaps. Now they have, by making thousands of improvements, eliminated the shower test. So that's, imagine, Mark talked about the finish of the body and in Tesla, and imagine the kind of finish that is required to, for you to actually eliminate the shower test, that you're so confident that it will not leak water through the gaps. Another thing about the design system that I learned is the managers telling the designers not to take decisions too early. In the Western world, this might seem, quite surprising, but the idea is to keep things open. Now, this is part as late as possible. This is part of what is now termed as set-based thinking. It's a Western terminology for what Toyota and the Japanese companies do in lean design. The set-based thinking involves juggling multiple solutions to each subsystem, both for manufacturing and the product design. So the set-based design evaluates these multiple alternatives. No alternatives, no acceptance of design. So because of this, you don't take the decisions early, you keep them open, and then you're working with the vendors in parallel through concurrent engineering. And therefore, actually you crash the whole design time. It might seem paradoxical that you do that even as you're extending the, you're keeping things open for decisions. Lastly, the point that Mark emphasized so well, lean design is system design. You have to design it at the system level and then go down. So clearly, friends, the time has come to revolutionize the design and development process to produce great outcomes for customers as well as society, while improving the health of the organization, which is delivering new products. And I believe that these principles apply not only to the physical world or not only to the assembly and engineering industries, but to process and chemical industries, and of course, to the information technology world. Thank you very much for this opportunity given to me to share a few thoughts with you today. I really appreciate it. And thanks, Mark, for your outstanding talk. Thank you.
Thank you, sir. Thank you. Thank you, sir, for sharing your valuable experience and reiterating the importance of the topic of today for any organization. Your words always gives the listener, more clarity and initiates a thought process, and that's what you are known for, and, and that's the reason we wanted to have you also in this session. So thank you so much for your words of wisdom. And I'm sure there's a lot more work, as you said, and there's a lot of takeaways. I'm sure the participants would have enriched their understanding of this topic.
Thank you.
On 1st July 2021, this chapter was inaugurated thanks to the efforts of our mentor, Mr. N. Ramanathan. So Dr. Rajkumar, Senior Vice President Operations at IREDL, in his maiden address as the first president of the Chennai chapter, presented his plan for the year that mentioned about running a training workshop on benchmarking. So today's session was just a beginning to see what is benchmarking, understand, and then, as our chief mentor also said, that we should probably look at a longer session with Mark. Certainly we'll take that. So with that intention, we thought we will kickstart something in that, related to benchmarking, and that's what today's session was. So I now request Dr. Rajkumar, President ISQ Chennai chapter, to offer his closing remarks and also felicitate the two guest speakers for the day. Over to you, Doctor.
Thank you, Nanda. Respected mentor of Chennai chapter and guest of honor, Mr. N. Ramanathan, the subject expert of the day, Mr. Mark, for his wonderful presentation. My dear EC members of Chennai chapter, ISQ members, industry friends, ladies and gentlemen, good evening. I think this was a very interesting session today. I think we would have heard after a long time, as Mr. NR was saying, and it was so crisp and short, but in depth. And there are a lot more things which we need to learn and take it forward. I think definitely, as we set in our objective, this is only a preview. We'll have further sessions on this benchmarking and lean design, probably with Mark and his colleagues. Coming to Mr. Mark, it was a very wonderful session, and I think you nicely put everything, and your point of benchmarking, saying that product knowledge and understanding is important, not copying. It's definitely no recordable thing. And your examples and the case studies on the Tesla and Mackie was wonderful. I think every one of the participants would have made note of it and would have been very useful for them. And of course, you made the lean design very easy and simple to understand for everyone. And you start saying that change the rules. And yes, of course, always, the engineering people always think, the excellence in engineering design is must, but you brought in the dimension that it should be, profit is the goal, work to targets. I think that is the key for success of any organization. And when you look at the design, and as you rightly said, that 70% influence is at the design stage. So I think this was a very wonderful session, and we don't want to stop here. Mr. Mark, we will take it forward subsequently, and we will plan how we can take it forward. It is my privilege and to honor and facilitate Mr. Mark at this occasion. I request Nanda. Thank you, Mr. Mark, for your nice session. Thank you once again.
Indian Society of Quality Chennai branch felicitates Mr. Mark Limage for his knowledge sharing session on benchmarking and lean design. Thank you, Mark. Thank you. That was wonderful.
Thank you. I'm delighted to have had the opportunity this evening. It's very kind of you to say the things you have. I'm very kind indeed, and I'm genuinely I'm blown away. Thank you very much.
And today's guest of honor and our chief mentor, who is instrumental in starting this chapter, and he has given us a lot of directions based on which we have set the vision. Based on the vision of the ISQ, we have set our objectives for the Chennai chapter, and it was very inspirational and motivational speech, sir, today. And you clearly link the TQM along with what Mark has said in terms of benchmarking and lean design, starting from the target quality, target cost, which all the TQM organizations today do. And you are linking on the glitches to the must-be qualities was wonderful. I think it is we never thought, and that was a wonderful linkage on must-be quality to attractive quality, even though we have all this, but these glitches definitely pull us down. And that was a wonderful thing which we learned from you. And the third point which you stressed is the continuous learning. I think nobody will deny that. I think continuous learning is very important, and what is the learning for the future is more important, and you have set it very nicely. And the last one, you talked about the set-based thinking, and I think all these things are very important for us, and it is a good learning for every one of us today. Thank you so much, sir.
Thank you.
So on behalf of the Chennai chapter, we would like to felicitate you on this occasion. Thank you, sir.
Thank you, sir. Thank you. Indian Society of Quality Chennai chapter felicitates Mr. N. Ramanathan for being the guest of honor for the knowledge sharing session on benchmarking and lean design. Thank you, sir. Thank you for your presence.
Wish you all the best.
Thank you, sir. Thank you. Thank you, sir. I thank every one of you for being with us today.
Let's move on to the final session of vote of thanks. Let me propose the formal vote of thanks for the day. First, I would like to thank Mark Limage for accepting our invitation and sparing his valuable time amidst his busy schedule. Thank you, Mark. I know how difficult it was to run a lean design workshop online. You were busy with it for the first time he was doing it, and it was a busy week for him. but somehow we were able to get him for this session. We also record our sincere thanks to our mentor, Mr. N.R. Sir, for his passion and commitment to work towards achieving the vision and mission set by ISQ. Thank you, sir, for accepting our invitation to be with us today. And your words of wisdom will something that we always want to have for all our programs.
Thank you.
Thank Dr. Rajkumar, President of ISQ Chennai chapter, and all the EC members for their support, without which this function would not have been as smooth as we see it now. This session is not complete without the participation and, in fact, I was keeping my fingers crossed with England playing and the fourth race. I think, I didn't want the match to be over so quickly, but I think it was all for, but we reached 50, the score of 50 for today's attendance, and all the 50 for your active participants, active questioning. I'm sure I'll take these questions to Mark and then I'll answer it to you offline. So the session is definitely not complete without your active participation. Thanks for attendance and active participation. So thanks to all the ISQ members and the other guests for making it another good event to remember for a long time. Thank you. So stay safe. And with this, we wish you good health, happiness, and prosperity. So signing off on behalf of ISQ Chennai chapter, Nanda, Secretary, ISQ Chennai. Thank you.
Thank you. Thank you.
Thank you. Thank you.
Bye-bye.
Bye.
Thank you.
Yeah, thank you.
Good night, everybody.
Thank you.
Good night. Thank you.
Thank you all.
Thank you
Thank you so much.